Cambridge AS Computer Science, Chapter 9, Algorithm Design and Problem Solving, Part 1. We start with Chapter 9 from the very beginning. And Chapter 9 is somehow about programming. I say somehow because actually we will not be directly coding. Actually, we will never be coding in the AS. The AS exam, you're going to sit for paper 1, that is theory, for paper 2, that is problem solving, and both of them are written. So you can do it all using pseudocode. Pseudocode is false coding. You can do it all with pseudocode. Okay. However, in my notes and in my explanation, I will be including Python codes, because probably all of you will be doing the A2. In the A2, you have 2 papers, paper 3 and paper 4. Paper 3 is theory. Paper 4 is practical on computer. Paper 4 is all in Python. So I cannot keep teaching you pseudocode in the AS for a whole year and then expect you to be very clever with Python programming next year. I have to introduce Python programming from the AS. Okay, I'm already introducing Python programming for candidates who are doing O-level computer science. Okay, so I will be doing now some Python programming, and I will be copying code and putting it in PyCharm. This is the programming interface you will be using in the A2 to do practical programming. Paper 4 in the A2 is totally on the computer. Okay, and then these codes will now be for you to be building skills for understanding. Okay, however, please, in paper 2, you are not allowed to write Python. You are only allowed to write pseudocodes. Okay, please, let's start with the chapter. I will start it in a very simple way. However, please get ready that the pace will be a little bit higher. So if you haven't studied O-level computer science, go and revise my recordings for O-level computer science. The full playlist is available on YouTube, and it is public for anyone to see. Please go through the O-level computer science as self-study. Otherwise, you will face difficulties with especially that programming part. Okay, let us start with computational thinking skills. Actually, I'm not going into programming right now. Actually, I will put lots of bases. This is the syllabus. This is how the syllabus goes. And inshallah, paper 2 will start in a very easy and decent way, and then goes rapidly to something little bit complex. Okay. Computational thinking is a problem-solving process. I have to teach you how to think about solving problems. What problems? There are no problems. The problem is the task you would like to program. So, for example, you like to create a program to calculate the average for a class of 20 students. This is your problem. And problem solving is writing a program to fulfill this task. So computational thinking is a problem-solving process where a number of steps are taken in order to reach a solution. Any program. However, later on, I will replace the word program with algorithm, because this is what I'm supposed to be teaching. A program is written in a programming language. A program is written in Python. An algorithm is a description of the steps to do the program. And this is exactly what you need to study for the AS. You need algorithms. So I will replace the word program with the word algorithm. Okay? So any algorithm will be a set of steps taken in order. So the order also matters. Okay? There is a sequence to reach a solution. The solution is the program or the algorithm that fulfills the task you want. Computational thinking involves abstraction. What is meant by abstraction? I will be teaching now what is meant by abstraction. And there are loads of questions about this in paper 2. Please, please, students are oriented towards earning marks. Also, I'm oriented toward this. When you get a question about abstraction in paper 2 programming, you say, okay, these easy marks are there for me. And when you collect all the easy marks, we start to work harder on collecting more challenging words. Okay, so we will study abstraction, and definitely it will be in the exam. And also decomposition, data modeling, and pattern recognition, and algorithm design. This is what we will be doing all the year. We will be doing algorithm design. Okay, so we need to study these things. What is meant by abstraction? Let us look at this. And there are loads of questions about abstraction in the past paper. Okay, and these things, they don't depend much on your knowledge of the O level. So let us start with it. Abstraction involves filtering out information that is not necessary to solve the problem. Okay, what does this mean? You want to program, for example, you want to write a program or write an algorithm to calculate the average mark of 30 students in the exam. Okay, so maybe you need to enter the student ID. Maybe you need to enter the student name, and definitely you need to enter his mark exam. Okay. Okay. So these are the important things you need to consider when programming. Let me give you example for a piece of information that is not necessary. For example, his age or date of birth. This has nothing to do with calculating the average. I would like the average mark, not the average age. So abstraction is about filtering out information that is not necessary. For example, if you want to write a program or write an algorithm to calculate the average mark in an exam, please do not consider the date of birth or the age of the student. This is what is meant by abstraction. Free your mind from this. Okay, so abstraction involves filtering out information that is not necessary to solve the problem. Abstraction gives us the power to deal with complexity. When you have a complex task, filter away things you don't need to make it simpler. Okay, an algorithm, okay, see the word algorithm is an abstraction of a process that takes input. Anything in programming takes input and executes a set of steps and produces output. So with any program, definitely there will be some inputs. That input for my example would be marks for 30 students. That's going to be the input. And then there's going to be some sequence of steps. We call this processing. Maybe you will, in order you want to calculate the average, probably first you will calculate the total, and then divide by that total by the number of candidates in the exam, maybe by 30, divide by 30. This is the processing. However, the result will be in the memory. In order for users to see the result, you need to print or you need to output. So you need to output information you want. Okay, so this is an algorithm that will take some input, do some processing, and produce some output. Okay, an abstract data type define abstract set of values and operation for manipulating these values. Abstract data type is somehow taught in the O level new syllabus of the O level. That's gonna be, for example, the query, the array. Okay, and also we will be teaching it inclusively, explicitly in the syllabus. Okay, so abstract data type, we don't know now anything about abstract data types. We will study them in the AS. Okay, okay, so this is abstraction. Okay, abstraction means filtering out unnecessary information so you can focus on necessary information You don't want your task to become very complex. Okay, that is the concept of abstraction. Next, the concept of decomposition. And this has been explicitly explained in the O level. Please go and listen to chapter 7 in the O level. You will find this much more in details. Here I will say it briefly. What is decomposition? Decomposition means breaking tasks into smaller parts. Okay, you would like to write a very big program, and it is very big and it is very complex, and you need to work on it in a team. You cannot just program the whole program altogether. You have to break it down into smaller tasks. So the program, I break it into module 1 and module 2. And then module is part of a program, not a whole program. Module is part of a program. Okay, so decompose, and this is decomposition. Decompose your program into 2 modules. Okay, module 1 and module 2. Okay, and if you think module 1 is very complex, is still complex, split it into even sub-modules. And if you think module 2, split it down. And if you think module 2.2 is still difficult, split it even more. This will be called stepwise refinement. What is the difference between decomposition and stepwise refinement? Nothing. Decomposition is the other word for stepwise refinement. And this is all in the O level. Very simple. And I'm explaining it here for people who are not recalling it, for people who have studied O level, and I'm teaching it from the beginning for people who haven't studied the O level. So decomposition means breaking down tasks into smaller parts. Decomposition is another word for stepwise refinement. See, this is stepwise refinement. This leads us to structure programming. This is very useful. Cambridge is teaching you very good programming practices, not just programming. So you structure your program into modules. These has so many benefits. For example, if you'd like to program the whole task all together, it's going to be very big and it's going to be very long, and you're going to fail and make many mistakes. If you split it into smaller parts, you can program each module independently, and then you test each module independently, and then fix it. It's going to be a smaller, maybe they say divide and conquer. Divide and conquer. You split things into smaller parts so you can easily solve them. Okay, there are so many benefits of modular programming. We will go through. I'm just telling few about them. So it is easy to program smaller modules. It is easier to find and debug. Debug is finding and fixing errors in programs. And also you can share. You can work in a team. You can share modules with other programmers. Okay, there are so many benefits of modular programming and stepwise refinement. Okay, we will go through this. Okay, this leads us to structured programming using procedures and functions. Okay, people from the O level knows that a procedure is part of a program that returns a value. A function is a part of a program. I'm sorry. A procedure do not have to return a value. A function returns a value. If you don't know this, go and study chapter 7 O level. I will make it available for you. I will make the playing list for O level computer science. However, it's in Arabic. Okay, I'm inventing this because I have an Englishman in my class right now. So I'm putting the recording all in English. How the O level, the recording is all in Arabic. Okay, English Arabic, because the science is already in English. Okay, but I'm here. I'm strictly talking in English because of the presence of that gentleman. Okay, Shabab. Okay, so functions and procedures. We will explain about them right now, today, inshallah. However, they are comfortably explained in the O-level. Okay? So, this is what is meant by decomposition. Stepwise refinement is the same as decomposition. So, it's the same diagram. Stepwise refinement is to break the problem into smaller steps until steps are easy to solve. Stepwise refinement is to express the algorithm in a level of sufficient details. These are detailed modules. To split a large task into smaller subtasks so that it can be programmed. Individual tasks are easier to solve. So see, these are advantages of stepwise refinement or decomposition, or we also call it modular programming. Individual tasks are easier to solve and to make the problem more manageable and understandable. Okay? Okay, what else? Very soon, I will refer to past papers. But please allow me to explain a significant part. So when I go to past papers, because questions are a mix of these ideas. Okay? Pattern recognition. Also, this is about computational thinking skills. Okay? Pattern recognition. What is meant by pattern recognition? Look at the task you are programming. Because there are some very popular algorithms. For example, if your program is about to create a sort or about to create a search, do not try to reinvent it, because this is already written in books and taught to computer science students. So if you find a pattern that you have already studied, okay, go and copy it or reuse it from what you have studied. We always say that you don't have to reinvent the wheel. The wheel is already there and people are using it and they know the equation for it. If you are to program, just go and get things that are already done. We don't blame you. We want you to be efficient programmer, and we want you to write efficient code. Okay? So pattern recognition means looking for patterns or common solution. Common solution, I talk about searching algorithms. They are taught in the O level. Go and study them. Okay? Or sorting algorithm. We will be studying them more extensively here and comparing their performance. Okay? So if you would like to do a search or sort, do not try to reinvent your search or sort. Just look at the efficient algorithms in textbooks and use them. We don't want your task to be harder. Okay? So pattern recognition means looking for patterns or common solutions to common problems. What are these common programs? So search and sort. Search and sort. Okay. Okay. Use these to complete the task in a more efficient and effective way. There are many standard algorithms to solve standard problems such as sorting and searching. Okay. You should have studied that. We will also be studying it in the AS. There is a chapter about sorting. We call it bubble sort. Okay. And then maybe we also in the AS, we need to study another way of sorting that's going to be called insertion sort. Okay. This is going to be taught and compare the efficiency between them. So my advice, if you are writing a program for any purpose and you need to do some search or some sort, look at textbooks and see how efficient algorithms for these are written and just make use of them. We don't mind. Okay? Okay, so this is pattern recognition. Look for popular tasks and see how they are done in textbook. Algorithm design. Algorithm design involves developing step-by-step instructions to solve a problem. Inshallah, we will have a lot of talking about algorithms, because algorithms are expressed in three ways, and we have to deal with the whole three. One of them wasn't in the O level. It's called structured English. This is algorithm written in structured English. This is so simplified. Structured English is English. You just express it. It's not a program yet. You express it in English. So it's English. However, it is structured. So it is like it is commands that soon will become algorithms, soon will become pseudocode. So for me, algorithm is structured English or pseudocode, not Python, not Python. Python is not an algorithm. Python is a code. Python is real programming. I have here Python code for your understanding. I will copy this and put it in PyCharm and run it and play with it. Also, I may send it to you and you start playing. Now it is playing, but next year it is very, very, very essential to be very, very skillful writing Python codes because of paper 4. Okay? Okay? And a flowchart. For me, an algorithm is a description of a program. An algorithm is a description of a program, or an algorithm is a design of a program. Okay, the algorithm may be in the form of structured English. So it is sentences and commands that they are really English, but they look like they are instructions for the computer. Okay, okay. Or in a diagrammatic form, and we call this a flowchart. Or in commands like this that are almost similar to programming, and this is called pseudocode. In your paper 2 AS exam, you are only allowed to write structured English, you are only allowed to write pseudocodes, or you are only allowed to draw flowcharts to express your algorithm. You are not allowed at all to write Python. You are not allowed to write a programming language. We will go through this and look carefully at what the exam is saying. If the exam says write pseudocode, it is like this. If the exam says draw a flow chart, it is like this. The exam will, if the exam says write a structured English for this algorithm, it is like this. And all of these are in the design stage. We will go through stages. However, these stages are in chapter 12. I have for paper 2, chapter 9, 10, 11, 12. And these are for paper 2 AS. Okay, we will go through system development life cycle. People who have studied O-level ICT know about system development life cycle. We will study this in chapter 12. And all of these are easy marks. All what I'm talking about now are easy marks. We will see and look at the exams, and also, inshallah, all these easy marks. The exam, Cambridge is very clever, makes the exam balance. It starts with very, very, very easy tasks, and then moderate and advanced, and at the end, a challenging task. Okay, let us first earn all the easy marks, and then more difficult and more challenging, and let us get all the marks. You are going to do A2. You need every single mark. Okay. Okay, so this is decomposition. This is pattern recognition about sorting and searching, algorithm design. Okay. Okay, let us talk about another topic, and then we go and look at past papers. Go and look at past paper, because this just one page may have lots of questions, and I would like to earn every single one. Transferable skills. Okay, let us discuss a little bit about it. In paper 2, in paper 4, in the A2, you have to write codes. And those codes may be in one of 3 programming languages. You may write it in Python, and Python is the easiest. Or you may write it in Visual Basic. They call it VB.NET, and it is okay. It is easy. And also, you may write it in Java. In Java, but Java programming is difficult. So nobody in Egypt is teaching Java. Most of the teachers are teaching Python, and I am among them. We used to teach Visual Basic, but then we found that Python is much easier. Okay, what if after you study my subject and you graduate or you go to the university and they find them teaching you another programming language, for example, that is called C++, or another programming, or then you go to the university and they see they are teaching you Java. Can you transfer the skills you have learned with me in Python to another programming language? The answer is yes. And this is what I'm here to teach. This is what is meant by transferable skills. Transferable skills. Okay? You can transfer your skills from Python to Java or from Java to Visual Basic. Actually, I am giving you all the skills on pseudocode, because pseudocode is the base for everything. Pseudocode gives the basis for all programming languages. This is pseudocode. Pseudo means false or semi. Pseudocode, almost a code. So you can transfer your skills from any programming language to another programming language. Why? Because in any programming language, you have variables. So if I teach you about how using variables, it's going to be the same. Any programming language has selection, that is if then else. And if I teach you selection, if then else, even using pseudocode, they are all the same. There are in any programming language, there are what is called loops and iteration. If I teach you this using any programming language or even pseudocode, it's going to be the same. So this is what is called by transferable skills. So this is very good news. Go and study one programming language, study Python with me, or pseudocode right now. And then when you face any new programming language, it will take you a day or two to transfer all your skills from the language you have studied to any new programming language. Okay, I am teaching you this now under the title Transferable Skills. Transferable skills. Okay, okay, let us read what is written. Knowledge and experience of one programming language can be applied to an unknown language. A programmer will be able to recognize control structures. What is meant by control structure? I will show you. If then else, case, both of them are called selection. And then for, while, repeat until, and the three of them are called loops and iteration. We also have what is called an array. We also have, for example, two-dimensional array and one-dimensional array. We have variables. We have functions and procedures. What is a function and what is a procedure? A function is a part of a program that returns a value. A procedure is a part of a program that do not return a value. Okay? Anything of these you studied in one programming language can be easily transferred into another programming language. Okay, Shabab? You should be able to recognize and understand in another language such things such as declaration. I will teach you now what is meant by declaration. Before you use a variable, you need to declare its data type. Declaration. Assignment, you put a value in a variable. Sequence, instructions are performed one after another. Selection, that is the if then else. Repetition, this is the for, while, repeat until. It's about repetition. Subroutines is a part of a program. Parameter pass, it is so difficult. We will learn about parameter passing. Modules, it's another way for subroutine. Program structure, input and output. There are input commands and output commands. In any programming language, they look familiar. They will be familiar for you. The programmer should have the ability to recognize. Please notice that this is an answer to a question in the past paper. And this is the way I teach. I keep my notes loaded with questions and answers from the past paper. Inshallah, we will come across it. But once in the exam, they ask you about what is meant by transferable skills. The answer was, the programmer should have the ability to recognize similar syntax, for example, assignment, variables, data types, common operation and symbols for functions such as addition, multiplication, division, or and or greater than. Anything in any programming language, you will be able to recognize. Okay, control structure, sequence, selection, iteration. Sequence is if then else. Iteration is a loop, for, while, and repeat until. Module, objects, procedures, and function. Object is about object-oriented programming. We will study nothing about object-oriented programming in the AS. We will study about it in the A2, inshallah. Okay. Maybe now I can find some questions. Let us go and look at past paper questions. Okay, so this is the very first page of my classified. See? So this is classified, chapter 9, algorithm design and problem solving. And this is the very first page of my classified. Okay? And this question is taken from 22 November, paper 21. I am showing this for two reasons. First, you know that this question is very recent. We are now 2023, and this question was in 2022. Because old questions, I consider them irrelevant. And also, there was a syllabus change in 2021. So anything that is 2021 or recent or after is the most relevant to us. So this question is very new and very relevant. And number two, to be able to pick up the mark scheme, because you need to go to the past papers and classify and mark schemes and open up 22 November paper 21 MS and go to question 2, and this is the mark scheme in front of us. Okay, please, first I would like you to try it yourself, because this is direct question for what on what we have been saying. Okay, a system is being developed to help manage a car hire business. A customer may hire a car for a number of days. An abstract model. What is meant by abstraction? We have just said abstraction is about keeping important details and filtering away unnecessary details. An abstract model needs to be produced. Explain the process of abstraction. And when you see this in paper 2 programming, you say, yes, easy marks for me. Okay, abstraction. Okay, explain the process of abstraction. What is abstraction? Abstraction, as being explained in the notes, is the process of keeping key and important information and filtering away unnecessary information. Okay, this is the explanation. And also, Cambridge do not like you to keep memorizing things. They like you to apply your knowledge. Okay. So we like to state 4 items of data that should be stored for each time a car is hired. You are writing a program about hiring or renting cars. Okay, what data you should consider? Okay, we said that unnecessary data will be omitted. Okay, you explain this. This is the process of abstraction. Okay, apply your skills in abstraction and give me 4 items of data that must be considered in a program to manage car hire business. Okay, first let us read from the mark scheme the explanation written for the process of abstraction. Abstraction is used to filter out information that is not necessary for the task. Or you can say the opposite, to only keep information and data that is necessary for the task. This is the mark scheme, ya shabab. Okay, and there is 1 mark for the explanation. And okay, let us talk about the data items: car ID, car registration, car type, etc. Anything from this category, information about the car itself. What else? Customer detail, ID, name, address, license, or other details about the customer himself. Start date of hire, return date, or alternatively, the number of days of hire. and definitely the cost. These are the pieces of information that you would like to focus. Anything else, you put them aside, and this is the process of abstraction. This is abstraction. Okay, what else? Identify two operations that would be required to process the car hire data. I think this is more like a database question. So the operation is to rent a car, return a car, calculate the cost. If there are damage, calculate the fine or the repair. So operation number one will be input customer details, input car details, input payment details, create a hire or start a hire, return a car or end a hire, check the car status, hired, available, written off, cancel a hire, process payment, or calculate hire cost. So these are the processing steps that would be required for processing hire data. See, we are a little bit away from writing codes. We are a little bit away from writing codes. Okay? Okay. Let us go back to explanation, because for me as a teacher, I find it very difficult to cut parts of questions according to the syllabus order, because questions are really mixed. Okay, let us get back to studying, okay? And then let us talk about algorithms. An algorithm is a solution to a problem expressed as a sequence of defined steps. An algorithm is the design of the program, not the program itself. Okay? Algorithm, and we will spend the whole year studying algorithms. So algorithm is the design of the program. The coding is writing Python, but an algorithm is a sequence step. An algorithm would be one of three, because here expressing algorithm. An algorithm will be in one of three: structured English, pseudocode, or flowchart. Okay? We said that before. An algorithm is a solution to a problem expressed as a sequence of defined steps. An algorithm is a sequence of steps that can be carried out to perform a task. Computer scientists are interested in finding good solutions. There may be 2 or 3 solutions. As a scientist, you have to become the best. Okay? A good solution gives a correct result, definitely. Okay? Takes up little computer memory. Do not use variables that are unnecessary. Okay? Use as less memory as needed, and executes as fast as possible. So try to make the steps as short and direct as possible. Okay? The solution must be concise, elegant, and easy to understand. For example, when you use variables with meaningful variable names. So a counter, we will call it count. The maximum, we will call it max. If you give variable names like X, Y, Z, as in mathematics, they will work, but the solution will not be elegant, will not be easy to understand. Concise, we will talk about this later, but just try to make a good algorithm. Expressing an algorithm, one of three things: structured English, flowchart, or pseudocode. When we design, we are in the design stage. We are not coding. When we design a solution to a problem, we express the solution, the algorithm. We will be doing algorithms using sequence of step written in structured English. Okay. Sometimes they ask you to write structured English, not write any pseudocode. And this is in the recent exams, and I call these easy marks. Okay. And also in pseudocode, or draw it as a flowchart. There are loads of examples about flowcharts and pseudocodes, and also recently there are many questions about structured. Structured English is the easiest. Let us do structured English. Structured English is a subset of English language. It's just English, okay? And consists of command statement. We make it look like commands, like go left, go right, move 5 steps, things like this. And it's not after you have written that and go and do. No, no, no. We make it concise commands. Okay, example. A program has been written to enter and display the results of a cricket match. Actually, this is an exam question. I copied it from old days and I'm presenting it for you. The winner team is the one scoring the most runs. It is assumed that the scores will never be equal. They will keep playing until one of them win. There is no draw. Okay? The following algorithm is written in structured English. So that was given as the question head. That was the question. So input home team name. So input the name of the team who is playing in his city. Input home runs. Also input how many points he collected. Then input away team name. Input the name of the other team that is a visitor. And input away runs, the number of scores, the score he has earned. Okay, subtract away runs from home runs and store this as difference. Okay, what is the difference between this and pseudocode? This is structured English. It starts with subtract that from that. If we write it in pseudocode, it would gonna be this. Difference is home minus away. Okay. Select the winning team. So how you're gonna program this? Select the winning team. Maybe it's gonna be an if. If home runs away greater than away runs, then winning team name will be the home team name. Else, the winning team name will be away team name. So select the winning team, store as winning team name. Output winning team name and run difference. So your program will output the name of the winner and the difference between the two scores. So that was the question, and I use it to present for you what is meant by structured English. This is an algorithm written in structured English. Okay, very easy. When the exam asks you to write anything in structured English, you say, yes, easy marks. Let us get them. Let us get them. And they will ask you not to write any pseudocode. So if you go and make it more difficult for yourself and write it as a pseudocode, you will get tired and get no marks. Okay? I will show you right now examples from recent past paper question very soon. Okay? And also they are showing you a typical output. A typical output. This is when the program is running. So away team name, we will write change Chargers, for example. Away team runs, we write 1, 2, 3. I'm sorry, home team name will be Chargers. Home team run will be 1, 2, 3. Away team name will be Tigers. Away team runs 1, 3, 6. And the output will be winning team was, and you get Tigers here. Who scored, and you get 13. So see, 1, 3, 6 minus 1, 2, 3 is 13. And then more runs. Let us write this in pseudocode, because at that time, the exam gave you the structured English, the screenshot, and is asking you to write it in pseudocode. Okay, let us explain it as much as possible, because some of you haven't studied O-level computer science. Please go and watch my videos. Okay, because here I need the flexibility of teaching AS to someone who has some knowledge about O-level. I need this. Okay, pseudocode. Pseudocode is a way of using keywords and identifiers. Identifiers means variables to describe an algorithm. Pseudocode resembles a programming language without following the syntax. With Python, if you mistype any word, it will not run. Here in pseudocode, it's acceptable without following the syntax of a particular programming language. So as you can see, pseudocode is something easier than programming. Okay, good for you. You only need to do the AS using pseudocode. Okay, example. This is the pseudocode equivalent of the structured English algorithm expressed in the previous example. Okay. Let us study this as a very good introduction to programming. Even if you haven't studied O-level computer science, you can follow me because I will go through it very slow. Declare home runs as integer. See, this is written in pseudocode. And declare is something in pseudocode. Okay? So pseudocode commands are all written all in capitals, all uppercase. Okay? And you have to write this by hand. You don't have computers in paper 2. So declare home runs colon integer. This is a declaration that you are going to use a variable called home runs. And that variable will store integer values, whole numbers with no fractions. Declare away runs. Okay, and this is another variable that's going to be integer. Declare difference, and it's going to be integer. So now you are studying or recalling about data types. So home runs is integer, away runs is integer, difference is integer. What about home team name? This is a string. It's going to store the name of the team, and it's going to be text. Text in programming, we call it a string. Declare away team name also as a string. Declare winning team name also as a string. Now I did declaration in pseudocode. Before you use a variable, you need to declare. However, sometimes in questions, they don't consider declaration. Sometimes I will show you exactly when you need to put declaration and when, for simplicity, it doesn't matter. Okay, now the code begins. Input home team name. So it expects the user to enter the name of the home team. And input home runs. It expects the user to input the number of the score he has earned. And away team name. Input then. I can show you the program running. Let us play with this. Let us play with this. Because I don't like to explain how programs will behave. Let me show how the program will behave. This code is all written in Python. I may send it to you, or it's already in my notes, to start practicing Python from now. All of you are going to do A2. You are desperate for Python skills. We cannot start Python in the A2 days. We cannot. Okay? Let us start practicing right now. This is PyCharm. This is the software that's going to be in your exam day in Egypt. I cannot guarantee what's going to be in your exam day, what software will be in your lab in other countries. So this is PyCharm, and this is the official integrated development package that will be in your exam in Egypt. I cannot guarantee what will be in other countries, but PyCharm is very, very helpful rather than writing your code directly using Python IDLE. Python IDLE is not offering you any assistance in error finding and solving. Okay, and look at this code. Okay, that was something from the A2 days. Okay, Let us go to this, and this is also from the A2. However, I can erase it. Okay, let us. Okay, allow me. I will create a new file, new Python, and I will call it yes. Okay, whatever. And I will just paste my code in it. Okay, let us run, let us play with it, because I don't want to take your time explaining how it will look like. This is how exactly it looks like. No, it is not. So this is AS. Let us run it from here. Okay, this is how it looks like. I have more details than it should be in the question. I say here, enter the name of home team. This is what's in here. We call this prompt. So, for example, it's going to be A, B, C. So this will be stored in the variable home team name. Okay? And enter the home team runs. Let us copy from the question itself. And then it should be 1, 2, 3. Let us write here 1, 2, 3. Now stored in the variable away team runs. Now is waiting for a value. Away team name. Let us call them X, Y, Z. Okay, now expecting a value for away runs. Okay, let us give exactly the same value here, 1, 1, 3, 6. And then, okay. Difference is the absolute of home runs minus away runs. What is that absolute? It means taking away the sign, the negative sign. This is mathematics. Taking away the negative sign. Because maybe that minus that is something negative. And I don't want to see a difference as negative. So ABS is absolute. Okay? So winning team was XYZ, who scored 13 more runs. And this is the if. And this is the if. Okay? This is unnecessary. This is the if. As you can see, it looks the same if you study it in pseudocode or if you study it in Python. Let us study it in pseudocode. If home runs away is greater than away runs, then winning team name will be home team name. So if home runs greater than away runs, then the winning team name will be the home team name. Else means if not. And as they will never be equal, as mentioned in the question, as they will never be equal, so I will assume if the home is not the winning, then the away will be the winning. Okay? Now I have two variables, one called run difference and another called away team name. So I can output winning team was, this is just some text to show on the screen, comma, and here goes the name of the winner from the variable called win team name. And then quotation space, who scored the space. Whatever between quotation will just show on the screen. And then you put the value of the variable run difference and then more runs. Okay, that is the pseudocode. Okay, what would you think will happen if there is a draw? Simply speaking, my program will work incorrectly because I didn't consider the case if home runs and away runs are equal. Here I simply, assume if home run is not greater than away run, then the winner will be away team, because the else is the opposite of this. And the opposite of greater than is smaller than or equal. So if there is a draw, the program will work incorrectly and will say that the away team is the winner. I can show you this, but actually I didn't consider this because the exam said they will never be equal. So comfortable. Okay, let us look at the code. So this is the code. Let us run it again and give two equal values. And this will be incorrect. Let us run it again. And you don't need to improve it right now. You don't need to fix this right now. Okay, so the home is A, B, C. And he scored 100. And the away is X, Y, Z. And he also scored 100. See, it is saying that the winner is X, Y, Z. This is incorrect. But this is the way I wrote my code. So if a home is not greater, then I will assume that the away is the winner. This is incorrect, but this will not happen because the question says they will never be equal. Okay, so don't bother yourself now. However, I would like you to consider how the output is formatted. So print, in Python, print is written in small case. In pseudocode, print is written in uppercase. Okay, in pseudocode, if, else, and end if. In Python, there is no end if. Okay, you already have this as a screenshot. Please go install Python and PyCharm. And then, because PyCharm is coloring text for you and is identifying variables for you. So for example, when you highlight winning team, this is the same winning team, this is the same winning team. Okay? And when you home runs, this is home runs. However, Python do not do any declaration. So that you need to say that this is going to be treated as string. And this input was going to be treated as integer. This will be string. This will be integer. And these prompts are extra from me. ماشي? So winning team was, and here the variable winning team, who scored, and the green color, the text is just text that will appear on the screen. And this is the run difference. This is the value of a variable counted from here, and more runs, and that's it. Okay, يا شباب? طيب. I will stop here. I will stop here. I will teach you about flowcharts next session, inshallah. However, I would like you to go through my classified. Okay, essential, not essential. This is about abstraction. And this question is 21 November, paper 21. Okay, so essential part items, these you need to consider when you do abstraction. Non-essential things you need to omit or ignore when you do abstraction. Okay, and then here also, identify 3 program modules. I didn't teach you about modules. Decomposition. Decomposition is about making modules. I will tell you more about this. So see, how far can you go? How far can you explain selection? Okay, if you can go up to page 7, that would be fine. Just try doing it. And I will cover this for you next lesson, inshallah. I hope everything is clear. Thank you very much for your patience and attention. Assalamu alaikum.